Alright, so today we're doing 6.2 day 2, and these are all story problems. So example 5, we have a straight road leads from an ocean beach at a constant upward angle of 3 degrees. How high above sea level is the road at a point 1 mile from the beach? So this gives us a diagram of what the story problem is talking about. So we have a straight road, and it's a mile long, which is 5,280 feet. And it slopes up at a degree of 3. So 3 degrees is your angle from the ground. So we're looking for how high it is above sea level after this 1 mile. So we're looking for this H over here. So given this angle, given the hypotenuse, we're trying to find this shorter leg. So this should be very similar to what we did yesterday. So what trig ratio could we use to find that H?
Sine.
Sine. So we're going to do sine of that 3 degrees. What is the sine of that 3 degrees equal to? H over 5,280. So this should look exactly like what we did yesterday. We're going to solve for H. And what do we get for H? 276.33. And that's feet, because our other measurement was in feet. And that's all that's asking for. So it's approximately. It's not actually equal to 276.33. It's approximately 276.33 because we rounded it and that whole deal.
Wait, don't change it yet.
Don't change it yet? Okay. There you go.
Okay, you're good.
I'm good now?
What's that say?
Feet.
Feet. Let's look at that.
Sorry.
No, it's okay.
Alright, so example 6. According to the safety sticker on a 20-foot ladder, the distance from the bottom of the ladder to the base of the wall on which it leans should be 1/4 of the length of the ladder. So 1/4 of the length of the ladder is 5 feet. So part A asks, how high up the wall will the ladder reach? So they give us this diagram that helps explain what's going on in the story problem. So we know that the ladder is 20 feet long and it's leaning up against this wall, and we know that it's 5 feet from the wall at the base. So question A is asking how high up the wall will the ladder reach. So we're looking for this height of the wall. So we've given 2 of the sides and we're asked to find the 3rd side. So what do we do to find that 3rd side? We use the Pythagorean theorem. So our hypotenuse is the 20, so we're going to have h squared plus 5 squared equals the 20 squared. And then we're going to solve for h.
$19.3649.
So h is approximately 19.36.
3649, but yeah.
Okay. So that's what we're finding for A. Now B asks, if the ladder is in this position, what angle does it make with the ground? So for B, we're finding this angle theta in the diagram. So using our original pieces of information, the 20 feet and the 5 feet, how can we find this angle? So it's cosine of theta. And what is cosine of theta equal to? 5 over 20. So this is where we plug in the inverse cosine, and you'll plug in the 5 over 20. And what do we get for theta? So theta is approximately 75.5 degrees. So that's all we had to find for A and B. So at the top of the next page, it's introducing what angle of elevation is and what angle of depression is. Angle of elevation, you'll have a horizontal somewhere. It could be the ground, it could be somebody's eye level, something. You'll have some sort of horizontal. Angle of elevation is when that angle goes above, is telling you that the angle goes above the horizontal. Angle of depression is telling you that the angle goes below the horizontal. So those will be important in the upcoming story problem. So just remember that elevation is above, depression is below. So for example 7, it says a flagpole casts a 60-foot shadow when the angle of elevation of the sun is 35 degrees as shown in the figure. We need to find the height of the flagpole. So in our figure it shows that we have our flagpole and it's casting a 60-foot shadow. And then we're told that we have an angle of elevation of 35 degrees. So the ground is our horizontal in this case, and we're going up 35 degrees. So that's what this 35 degrees is showing. And we're asked to find the height of the flagpole. So we're looking for this right here. It's H. So given this angle on the side, how can we find H? So H is going to be the tangent of 35. And what are we setting the tangent of 35 equal to? H over 60. So again, this is exactly like the problems that we did yesterday. Solving for H. You get that H is approximately 42.01. So the height of the flagpole is approximately 42.01 feet.
Doesn't mean I'm going to do it. Wait, go back.
Go back.
Hey, you're my dad, you guy.
Okay.
Okay, so example 8. Example 8 says a wire needs to reach from the top of a building to a point on the ground. The building is 10 meters tall and the angle of depression from the top of the building to the point on the ground is 22 degrees. How long should the wire be? So first of all, we're looking for how long this wire is. So this wire is going to be W. That's what we're looking for. And we're given that our horizontal is off of the top of the building. So that's what this dotted line is our horizontal. And we're told that we have an angle of depression of 22 degrees to the wire. So that's what this angle is here, is our angle of depression to the wire. So we need to find W, and we're given that the height of the building is 10, so it's 10 over here as well, if it makes it easier to see. But we need to find this angle. So we're given this 22 degrees, and we need to find this angle.
68,
And it's 68, why?
because that's a complementary angle, so subtract 22 from the 90.
Yep, it's a complementary angle. This is actually a 90-degree angle from the horizontal to the building. So we can take 90 minus the 22, and we get that it equals the 68 degrees. So we get that this alpha angle is 68 degrees. So now that we have that angle, how can we find our W? Our W, remember, is our hypotenuse in this case, because it's across from this right angle that it's making, that the building and the ground make. So which trigonometric ratio can we use? Cosine. So we're going to use cosine of our 68 degrees. And what is our cosine equal to? 10 over our W that we're looking for. So we're going to solve for W.
So tan versus cosine 60.
And what do we find for W? So our W is approximately 26.7, and that's in meters. So our wire is approximately 26.7 meters long. And our final example, example 9. A person on the edge of a canal observes a lamppost on the other side, with an angle of elevation of 12 degrees to the top of the lamppost and an angle of depression of 7 degrees to the bottom of the lamppost from eye level. The person's eye level is 152 centimeters. So for part A, we're looking for the width of the canal. So in our picture, we've got our guy, he's standing over on this side of the canal and he's staring at this lamppost on the other side. So for part A, we're looking for our horizontal. So we're looking for how long it is from our guy to the lamppost. Now, do we know anything else besides what is labeled here? Can we tell that according to our horizontal, this section of the lamppost should be the same height as our guy? Because our horizontal goes straight across and our ground levels are equal.
Yeah.
So this should also be 152.
That it should.
And this is our W that we're looking for, our width of the canal. So now, given that information, can we find W? Okay, so how are we going to find W?
You got two parallel lines with some angles and
Using the trig ratios.
Oh, okay, well, what I said before too.
So we're going to use what?
Sine.
Sine?
Not sine.
Tangent?
Yeah.
Which one are we going with?
Tangent.
We're going to go with tangent?
No.
Because we've got the opposite over the adjacent side. So we're going to go tangent of 7 equals 152 over W. And then again, solving for W.
One second. It wasn't showing too
So our W is approximately 1,237.94, and that's centimeters. So now part B wants to know the height of the lamp post. So we already know a portion of the lamp post is 152, but we have to find the remainder of the lamp post. So now we know W because we found it in A. So can we use this triangle to find, we'll call this H?
Yeah.
Okay, so what are we gonna do to find H?
Tangent of.
Tangent of 12. And what is tangent of 12? H over what we just found, the 1037.94. So then we're gonna solve for H. And what do we get for H?
263.132.
263.13. And that again is in centimeters. So now, that's only part of it. We have to find, so now we found H, and we already had the 152. So now we're just gonna add the two up, and that's how high our lamp post is. So we have the 152 plus the 263.13. And what do we get? 415.13 centimeters. So the lamp post is 415.13 centimeters tall. So the last 2 pages of the packet are your homework. It's more practice of the story problems.